All right, guys, welcome back for tonight's session. Again, we're still in the routing section. We're going to go ahead and try to cover two sections tonight. So we're going to talk about equal-cost multipath routing, ECMP, and we're going to also talk about one of my favorite security methods within routing. One of my favorite topics is reverse path forwarding, or RPF. Okay. Hopefully, after the end of this, you guys will be able to demonstrate competency of both of those topics. Okay. So ECMP, let's go ahead and jump right into it, right? Right. We talked about having different routes, right, to the same destination, right? We talked about the different route attributes, right? That'll be in maybe a router, a layer 3 device that's supposed to pass traffic, right? All of these things to go ahead and identify the best route to a destination, right? So what happens when we have roughly like what, two or more routes of the same type, right? And to the same destination that share the same values. I mean, all the way down to the metrics, metrics being our tiebreaker, right? What happens when they share all those same attributes, right? Well, what the Fortigate is going to do is going to install all of those routes into the routing table. And it's going to load balance, right? Meaning sharing the load of that traffic across all of the routes. Okay, right? And what is this called? This is called equal cost multipath routing. Okay, so if you plan it properly, right, you design your network properly, you can actually go ahead and design, right, your layer 3 device or your FortiGate to go ahead and perform several different types of load balancing methods when it's participating in ECMP, right? So it has 4 different methods that you can go ahead and configure, right? So those 4 methods, right? Sessions, right? As soon as traffic is being sent from a host within your network that has to go out, sessions can be balanced among equal routes depending on the source IP address, the source and destination IP address, the route or interface weights, right? Or the interface volume thresholds, right? So we're going to dig deep here, right? So source IP method, right? All traffic originating from the same source IP is expected to use the same path. Never going to change. Okay. The source destination IP method, right? It works kind of the same, right? But when that strategy is being used, right, it factors in the destination IP as well. So whenever it's choosing, right, whenever it's trying to choose, which path should I go ahead and use? It's considering both the source and the destination to go ahead and select a specific path to go ahead and send that packet. Okay, right? Let's talk about the weighted, right? The weighted portion, right? So the FortiGate, right? It's going to go ahead and distribute sessions with different destination IPs, right? By generating a random value to identify the route to select, right? To stay along with that session, right? Because of course firewalls are stateful, right? With the weighted one, right? That's what it's going to do. It's going to go ahead and distribute sessions, right? With different destination IP address, right? By generating a random value. When it generates that random value, it's going to go ahead and identify, with this value, I'm going to go ahead and use this path. With this value, I'll go ahead and use this path, right? The probability of selecting one route over another is based on the weight value of each route or interface. Okay. The higher the weight value is, right, the more likely that will be selected, right? That path will be selected.
I have a question.
Yes, sir.
So the weight value is, I think I heard you say, I'm just clarifying, it's random. How the value is chosen, is that what you said or no?
So, and let me go ahead and repeat. With the and I don't know if you know the concept of XOR. Are you familiar with that?
No, I'm not.
Okay, cool. So with destination IP addresses, it works similar to XOR, right? With a lot of these methods, right? the FortiGate's going to see the packet, see the destination IP, generate a random value, right? By just looking at that destination IP. And it's going to say, with this value, okay, I'm going to give it, that's going to be that value, right? That's going to be its weight. Cool, I'll go ahead and select this path for this packet. That's all it's going to do.
Okay.
Make sense?
Yep.
Okay. We don't have to get in depth with XOR. That's not what the exam is asking for. But you guys just have to know about that method, okay?
Got it.
All right. So there is an additional method, right, called usage base, right, or spillover, right? You guys probably seen that whenever we were talking about SD-WAN, right? In usage based load balancing, FortiGates, they use a primary route until a traffic volume threshold, so maybe it hit roughly 70% or whatever you have configured is reached, then it's going to go ahead and use the next available route, right? And this is still equal cost multipath, right? So again, it's going to have the same values, attributes, or what have you, right? For multiple routes, right, to the same destination on that router. With usage based load balancing, it's going to say we're going to use this one path first. Once it's hit its threshold, we'll go ahead and go to the next one. Okay, that's how it load balance that traffic. Okay, right. So, last but not least, if one of the ECMP routes fails and is removed from the routing table, the traffic is routed over the remaining routes. My Kiva wouldn't have to go in, make any configuration changes, anything. It's auto magically going to go ahead and say, hey, we have other routes that were participating in ECMP. One path being gone, doesn't, stop us from performing our job. Make sense?
Yep.
Okay. And we'll revisit it. We'll do a lab on it. I don't want to get in depth just because it's gonna force me to have a conversation with you guys about XOR, which of course is in the weeds, and it's a higher level of the NSC. So I just want to stay at the level that we're at. Okay. And it goes in depth into routing and switching. So we're just gonna stay where we're at with that one. So, right. So configuring ECMP has to be done in the CLI. Okay. Right. So by default, right, FortiGate sees in its routing table, right, multiple routes for the same destination, though it has the same attributes, right? It's automatically gonna, hey, we're gonna do ECMP, but we're gonna use the source IP method by default. That's gonna be the default method. If you want to change it, you're gonna go ahead and have to go to the CLI, as you see, right? Config system settings, set, right? v4-ECMP mode. And of course, you'll be able to choose the mode and all the four modes that we talked about: source IP, weight base, usage base, source destination IP. Okay. And of course, right, for weight base, you guys see, we can go ahead and define those weight values per interface or per route. We can go ahead and do that. All right. All right. For spillover ECMP, right, as far as the thresholds or what have you, as far as usage based, right, we can go ahead and configure, right, depending on the bandwidth of that interface, we can say, hey, here's the threshold, right? So maybe I have a gig interface, right? If the traffic that's traversing this interface, if it reaches 800 megabits per second, this is the threshold. Use the next path. Use the next path to get to the destination. Does that make sense?
Yes.
Okay.
Yes.
All right. So let's go ahead and look at this example, right? So we see the routing table. We have two paths, right? To go ahead and get to 10.0.4.0/24, right? That's a server on the right. Okay. The FortiGate, right, has a path over port 1, path over port 2, right? We're using the default method, right? Source base, right? So the FortiGate, it's going to go ahead and either route that traffic, right, either port 1 or port 2, right? Source IP base, right? It's going to go ahead and do automatically with port 1. Okay? If port 1 ever loses connectivity, we're going to go ahead and use port 2, go ahead and deliver all that traffic to the 10.4.0 network. Okay? All right? So again, want to reiterate, ECMP allows you guys, Fortigates, to maintain multiple links to the same destination, as well as provide built-in failover. Okay? 2 birds with 1 stone. You guys saw this before with SD-WAN. Okay? You guys can go ahead and deploy this in your network as long as you have the resources, the bandwidth, and what have you. You configure it properly, right? As long as, of course, you're using business applications that may be mission critical or what have you. You know, you can use policy-based routing. You can use this, right? This is another method you can go ahead and use along with policy-based routing or SD-WAN or what have you to make sure that provide that SLA of or that guarantee of 99.99% internet access, right? So it all helps with you guys deployment. Okay. Again, with these multiple links, it will load balance the traffic across the links. Okay. Now, keep in mind, whenever we are doing ECMP, we have to make sure we put in the right firewall policies in place to allow traffic to go over both of the interfaces. You can't just have a policy for port 3 to port 1 and expect the traffic to be load balanced. It has to be source port 3 and then the destination, right? And the outgoing interface, port 1 and port 2. Okay. So of course you have to go into feature visibility, enable multiple interfaces, boom. Okay. All right. So again, ECMP, amazing solution, right? To go ahead and maintain multiple internet connections, right? Again, I'm going to tell you guys, short and sweet, me working in a prod environment, enterprise, just like you guys. SD-WAN is the future, right? It's here to stay. It's going to do all of this, right? But of course, if you don't want to go ahead and do that, SD-WAN is a topic in itself. You can always use ECMP, use some of the methods that you guys already learned in this chapter to go ahead and load balance, provide failover, and to give WAN assurance to your customers. Okay. All right. So section review. So first question, what is the default ECMP method on a FortiGate? Is it A, weighted, right? Or is it B, source IP?
Can you say that one more time?
So what is the default ECMP method on a FortiGate? Is it A, weighted, or is it B, source IP?
Source IP.
Okay, good job. All right, so question 2. How does a FortiGate load balance traffic when using the spillover method in ECMP routing? Is it A, sessions are distributed based on an interface threshold, or is it B, sessions are distributed based on route weight?
Can you repeat the answers again?
Sure. So I'll do the question 2. So how does the FortiGate load balance traffic when using the spillover method in ECMP routing? Is it A, sessions are distributed based on interface threshold, or is it B, sessions are distributed based on route weight?
It's B, route weight.
I thought, is it? Wait, okay, I'm confused.
I'll let you guys talk amongst yourselves.
Wait, I kind of just rejoined, sorry. So Ian,
I'm gonna go with A.
Why?
Because I thought weighted had its own option. I think I can't remember the term that you use for when it's weighted, but I don't think it was scalable.
okay.
but I can be wrong. I'm not saying that I'm right. I'm just sticking with my answer.
I'm sticking with B because I think it's the weight, but I could be wrong.
Okay. So the answer is A, right? So
A.
load balancing traffic with and again, I use a different term for it, with the usage, right? Usage method, or of course in the question it said spillover method, right? It uses, right? Sessions are distributed based on interface threshold, not the weight.
Okay.
Okay.
Yeah. Got
All
it.
right. Right, guys. Let's go ahead and move on to the next section. I think we're good on time. All right, so now we're going to go ahead and talk about reverse path forwarding. Okay. I think you guys are going to get this. You guys are going to find this fun. It's going to make a lot of sense as far as you guys trying to understand routing and switching, right? So packets, right? Sometimes they're dropped for routing and security reasons, right? I'm going to say it again. Packets are sometimes dropped for routing and security reasons, right? RPF is a mechanism that protects the Fortigate and your network from IP spoofing attacks, right? It checks if there's a route back to the packet source. This check is run on the first packet of any new session, okay? There's two methods of RPF. It's either loose or strip, okay? We'll take a look at some diagrams of how that looks like. Okay, so let's go ahead and look at this diagram, right? So we're looking at this network, right? We have, right, the FortiGate in the middle. We have user A, we have user B, right? User A, 10.0.1.0/24. User B, 10.0.2.0/24, right? As far as the WAN connection from the FortiGate, right? And of course, we have our user C, who's hanging off port 1, 10.0.3.0/24, right? So, right, we got a cloud in the middle of user A and user B, right? So, incoming internet traffic arriving at WAN 1, right, is accepted because the default route is a valid route back to the source. Okay? So if we look at the default route, 0.0.0.0, quad 0, or the default route, right? We have a route that's towards 10.0.1.254, right? We can assume, right, that's WAN 1. That's WAN 1's gateway. That's our static route, okay? So we know how to get back over there. However, right, we have two other interfaces, right? And those two interfaces, right, they do not route some incoming traffic, right? Port 1 and WAN 2, right? So port 1, right, they don't route traffic between the subnet for user C, right? They don't, right? And then there is no active route for that subnet through port 1. Okay, so through port 1, we don't know how to get there. We don't know how to get to the 10.0.4.0 network. We don't see that in our FortiGate. Okay, so what's going to happen? The FortiGate is going to say, hey man, I'm going to go ahead and drop this. I don't know where to send it, right? So if user C tries to go ahead and send traffic, it's going to send traffic maybe to user A. The FortiGate's going to say, hey, I see this is the source IP, but do I have a route in my routing table for it? Nah, it failed the RPF check. I'm going to go ahead and drop this traffic. Does that make sense?
Kinda.
Okay, let me do it again, right? So in this scenario, user C is trying to send traffic to user A. Okay. In our routing table for the FortiGate, if you look at the slide, we don't see a route, an existing route for the 10.0.4.0/24 network, do we?
No.
Okay. What RPF does, it checks for an active route back to the source IP through the incoming interface. Okay. For this diagram, the incoming interface is port 1, right? User C is trying to send traffic to user A. When that traffic from user C gets to the FortiGate, right? FortiGate's going to look at it. It's going to say, oh, Layer 3. All right, let me go ahead and look at the source IP. Okay, excellent, right? Let me do the RPF check, and let me go ahead and take a look at my routing table, right, to do that RPF check. Do I have a route for the 10.0.4.0 network? I do not, do I?
No.
So this packet has failed the RPF check because I do not have a route back to the source, right? So I'm going to go ahead and drop this packet.
Okay, gotcha.
Okay.
Mhm.
Let's use another example with this diagram. User B, being the new source, is trying to send traffic to user A. User B exists on 10.175.3.69. We'll say the 10.175.3.0 network. It's trying to send traffic to user A. Okay, user B sends traffic, right? Fortigate gets it. Does the Fortigate routing table has a route for the 10.175.3.0 network?
No.
Okay. All right. So it is going to go ahead and fail the RPF check.
Okay. So the only one
Okay.
that really worked is the 10.0.1 network because it's a route on the routing table.
Because there is a route that exists for it in the routing table.
Okay.
So if user A wanted to send something to something that exists, maybe a network that exists on the firewall, so maybe 10.0.2.0 or 10.0.3.0, it's going to be able to send it because a route for 10.0.1.0 exists on the routing table. So it's going to pass the RPF check.
Okay.
Make sense?
Yep.
Okay. So how can we fix this, right? How can we go ahead and fix this network, right? We can go ahead, right? Let's say this is Antoine's network. He can go ahead and add some static routes, right? He can go ahead and add a static route for WAN 2. He can also add a static route for the 10.0.4.0 network and make the next hop be the 10.0.3.254 10.4 IP address, right, on that subnet. So us doing that, if user C now tries to reach out to user A, the FortiGate's going to go ahead and do its RPF check and say, oh, man, I see it in the routing table. Go ahead and send that traffic, right? It's checking the source because, again, it needs to. Firewalls are stateful, meaning that they follow sessions. To follow sessions, it needs to know, hey, where it came from, where it's going to. Okay? The most critical part is where it's coming from. If I have a route for where it's coming from, I know what to send it back to track this session. Okay?
Yep.
Make sense?
Yeah. Seeing
Any
this slide helps a lot with
Okay.
it to fix. Yeah.
Okay. Okay. All right. So stay with me. It's going to get a little bit tricky. So there's two different types of RPF methods. We got strict and we got loose, meaning we can enforce RPF loosely or we can go ahead and enforce it strictly, right? In loose mode, right, the packet is accepted as long as there is one active route to the source IP through the incoming interface. It does not have to be the best route, just an active one, okay? In strict mode, FortiGate checks that the best route to the source IP address is through the incoming interface. The route not only has to be active, as in the case of loose mode, but it also has to be the best. Okay? You can go ahead and disable RPF different ways, as you guys see within the slide. We can go ahead and go into system settings, config system settings, say set asynchronous traffic mode, right? Asymmetric routing. We can go ahead and disable that or enable it, however you want to do. Go ahead and go into the actual interface, select the interface and say, hey, set source check. We can say enable and disable. right? We could do all this thing, right? And us going into the interface disables it at the interface level, right? Of course, enabling asymmetric routing, right? It'll go ahead and disable RPF system wide. We can do that. I wouldn't recommend doing it system wide. I would say if you have a design in mind, do it at the interface level, okay? But again, please know what you're doing whenever you do this. This is a great feature, right? It's not just on FortiGates, it's on a lot of vendors by default. Okay. It actually, from a routing and switching standpoint, it adds that level of security to say, hey, let me go ahead and check this before I start shipping packets right out of my interfaces. Okay.
I have a question.
Yes, sir.
So I get what causes it to go loose and strict. But what is the firewall actually doing, like when it's going loose mode rather than strict mode? Like, is it a difference how it's sending the packages, or it's just not dropping them?
No, so good question, right? So loose and strict, right? It's a matter of, loose being, hey, as long as a route exists, I'll go ahead and pass it, or strict mode, right? And we'll put it in the scenario of multiple interfaces, right? Loose mode, we have two interfaces going back to a source. As long as we have one, that's fine. We have one path to a source is the minimum, we're fine. And it's a decent, path back, perfect, right? Strict, it's going to say, hey, I need the best link, right, out of these two links to get back to the source. If it isn't the best one, it's going to fail the RPF check.
Okay. So you
Make
can
sense?
choose, yeah. So you pretty much choose which one rather you want, loose or strict. It's not like both are always active. Okay, I get it.
Exactly.
Okay.
Exactly. Good question. All right. So let's talk about this, right? We got our diagram. We got user A, right? 10.0.1.1/24. We got user B, 10.0.1.2/24, right? And we have the subnet, 10.0.1.0/24 that's hanging off of port 1. Okay. We have user C, right? We got 10.0.4.1, right? That's our destination there, right? And of course, it connects to WAN 1, right? We got that there. So we are good to go, right? So let's talk about this, right? So 10.0.4.1, right? It sends user A, right? It sends a SYN packet, right, to 10.0.1.2, right? But what is it doing, right? It's spoofing, right? It spoofs the source IP of 10.0.1.1. So if you guys see on the right, it says, hey, I'm going to go ahead and send a SYN with 10.0. I'm going to switch my source IP to 10.0.1.1. I'm going to go ahead and spoof it. The FortiGate's going to get it. It's going to say, oh, perfect, right? So, Don, it gets the packet. We're looking in the routing table. The routing table is going to say, oh, I have a route that exists for 10.0.1.0, but it's behind port 1. Even though this packet from a bad actor came in on WAN 1. Since I am using the loose method, as long as I have a path to 10.0.1.0, and I'm using the loose method, oh, hey, I'm going to go ahead and allow this traffic to process. And now this bad actor is able to process an attack.
Okay, I see.
Right? So user B will go ahead and respond to it, say, oh, thank you, right? It'll go ahead and send a SYNAC, right? Because we're talking about a three-way handshake, right? TCP three-way handshake. It'll send a SYNAC, right? Back to the real device, right? Maybe user A, right? User A is going to say, oh, I wasn't expecting a send act. All right, this is weird. It's going to go ahead and respond with a RST packet, right? A reset. It said, hey, dude, I don't know what you're sending, but I'm just going to go ahead and reset this. And now we have a potential attack. So loose, you can leave it as loose. That's perfectly fine. Just understand what you're opening yourself up to.
Now, if you leave it as loose, I guess what do policies come in place as like a form of security or no? Like,
Nope.
wow, okay. So loose doesn't seem good at all.
It depends. And let me correct myself. A policy would, right? So if we have a northbound policy, right, you typically wouldn't have a southbound policy, right? But a northbound policy would protect this as well, right? But let's not focus on a diagram being WAN to LAN, right? What if it's LAN to LAN? Somebody got into your network that's maybe a guest on your site, right? But in plain sight, he's a bad actor. He or she is a bad actor. He, she, they, bad actor. They go ahead and do that. They're able to go ahead and mimic a host and do this. Why? Because a path exists on the FortiGate.
I see.
Make sense?
Yeah.
Okay. And I want you guys to see, right? How do we know within the CLI that it is running the loose RPF method? If we go to system settings, we see set strict source check, it's disabled. Okay. So same scenario now, right? So what happens if we're using strict RPF, right? Right, same thing, right? User C, it's going to go ahead and spoof its source IP address, right? What the FortiGate's going to do with the strict method, it's going to go ahead and drop that packet, right? Even though we have a active route to the 10.0.1.0 network, it's not the best route coming through the WAN interface. Okay, so we have a path back to the source, back to user C, right? But the FortiGate's going to say, but I have an actual path back to 10.0.1.0 that's a little bit better and has a better administrative distance than what I received this on, right? On this static route, okay? The static route was it has a administrative distance of 10, right? That's where my packet came from. But I have a better path for my connected with an AD of 0. Now I'm going to go ahead and drop your packet, homie. Does that make sense?
Yes.
Okay.
Yes.
All right. But, right, we can enable, strict mode all we want. Sometimes it can populate some false positives, right? If we're using, dynamic routing, what have you, right? If we're using maybe OSPF, right? Something may happen, right? Within, calculation or what have you, and maybe the path to a destination or something, and routes can go ahead and change, right? And what they can do is they can cause the FortiGates to go ahead and drop legitimate packets each time the preferred route changes, right? So Don, just like you said, right? We can use loose mode. It's perfectly fine, but we have to use it in unison with firewall policy to go ahead and block that spoof traffic, right? Instead of using strict RPF. And you can use strict RPF. You just literally have to know what you're doing if you're going to do that, okay?
Gotcha.
All right. So with that being said, right, we have gotten through the RPF section. I'm going to ask you guys 2 questions, okay? So first question. What is the default RPF check method on a FortiGate? Is it A, loose, or is it B, strict?
Can I get a second to think about it? Wait.
You're killing me, Smalls. Come on, Don.
Is it strict?
Yeah, I'm gonna say strict because it says when you do when you type the command, you have to type it was like disabled.
disabled.
So I'm assuming that it's automatically enabled.
Oh, loose is the fault.
Oh wow.
There we go.
Okay.
Okay.
It did say default. Let me add that to my notes.
Okay. All right. Next question. Which route lookup scenario satisfies the RPF check for a packet? Okay. Is it A, routing table has an active route for the destination IP address of a packet, or B, routing table has an active route for the source IP of the packet?
What was the question again?
Which route lookup scenario satisfies the RPF check for a packet? Is it A, routing table has an active route for the destination of the packet? Or is it B, routing table has an active route for the source IP of the packet?
It's B.
B.
From the
There,
source.
Source.
there we go. There we go. All right, guys. Great work. We have finished 2 sections tonight, right? We just got 2 more to go within routing, okay?
Alrighty, sounds good.
Sounds good.
All right, guys. You guys have a great night, okay?
You too as well. Take care, guys. Bye.
Bye.
Bye.